This is real-time example of finite automata. For example, lift and coffee maker, how the system will work, how we are going to represent through the finite automata. Finite automata, it is a mathematical model. It will provide the working principles of any system. So this is a finite automata. We are having 5 tuples like states, input, transition, initial state as well as final state. For example, lift, how the lift will work. We are using the state, ideal state, either moving up or moving down, or doors open and doors closed. So this is the basic activities of the lift. Here, what is the input? Maybe whenever you are pressing the button, the door may be opened or closed and arrive at the particular floor, and again but we are reaching the particular floor, again it will open the door as well as close the door. So the same activities again and again it will happen. And one more function is there, that is a transition function. Transition function means the systems move from one state to another state. For example, here the lift start from ideal state to either moving up or moving down. Otherwise, ideal state to either if you are pressing the button, the door may be open, and again if you are pressing the close button, the door may be closed. So like that we are having the transitions, and also we are having initial state, always ending state. So the same representations we are using finite automata also. And one more example, real-time example, copy maker. So what are the state may be copy maker? Idle, brewing, ready, dispensing and complete. So this may be a input. Whenever you are pressing the button, the brewing will be started, and after completing brewing, the dispense button may be enabled. So after dispensing over, again it come back to the ideal state. So the same thing represented as a transition function as well as transition diagram. So this is a representation of transition function. Here the transition functions represented as a delta. That is, we can say mathematical notation for transition functions we can represent as delta. For example, so this is a transition diagram for finite automata of coffee maker. So initially started with ideal state, then it will start from brewing, then brewing to ready state, and ready to dispensing, then finally the dispensing to come back to the ideal. So the same process repeated again and again, but it will start with ideal and also ended with ideal state. But sometimes it may be stopped any other state also. So we are having different applications. Based upon the applications, we can set the initial state as well as final state. In later we will see the different examples. Here the transition functions are represented like this. So delta of idle from brewing. So that's why we can represent here the transition of idle comma input is starting and it will goes to brewing. So like that, at any real-time example, at any mathematical problems, at any computation problem in the system, we can represent through the finite automata. But the finite automata, it will handle the problems at limited only, that is in the sense of limited memory only. So this is a major drawback, but almost we are using this same concept in different applications. in compiler also, in automation also, in n number of applications we can use, but concern the memory, we are using simple applications. So after that we will see the different automations, either push down automata, Turing machine. It will handle the huge amount of memory. Thank you.